My name is Microfiche. I am a software engineer, and today I'm here to talk to you about data. That is, about information that is stored in some physical place. You see, the history of humanity and the history of data go hand in hand. The first thing we wrote down on a cave wall somewhere, that was the moment the data came through existence. Think of data as knowledge or information, but just made physical, written down, stored somewhere. For the vast majority of our history, we've used what I like to call primitive data storage to do this. We started out recording our information directly into our environment. We wrote on cave walls. But as time went on, we sort of pulled that out into a more convenient portable form. First it was stone tablets, but before long we had scrolls, and then we had books. Our information became increasingly portable, and the manner in which we encoded it became increasingly sophisticated. By the time we had books and the printing press, we were information machines. We were capable of wide distribution of our ideas. So why have I grouped those primitive objects together? Well, what do they all have in common? Sorry, wrong direction. What do you need to access it? Just the object itself. In this case, it's a book. Advanced data storage, though, a little bit different. Starting about 150 years ago, the Industrial Revolution kicked in. A whole new class of information storage arrived on the scene. They were driven by advanced technology and new methods of communication. Ideas spread very quickly. What differentiated these mechanisms from the earlier ones? Capacity. Even the earliest versions of these technologies vastly outperformed more traditional means. Let's start out with a sheet of paper as our standard unit of measurement. Microfiche is the first advanced data storage that came along. You can shrink things down to about 1/4 of 1% of their original size. You can get 95 pages on a single sheet of Microfiche. Next up, magnetic tape, about 100 years later. The most primitive version stored 128 characters for every inch of tape that went by. So by the time you had a 1,200-foot long reel, that's about 618 pages. A couple years later, the hard drive came along, vastly increased to more than 1,700 pages. Just on the earliest gigantic hard drive, 5 megabytes. Think about that. Then the optical disc, about 10 years after that, more than 100,000 pages on a 12-inch disc. It's amazing. But how do we access that data? Well, just like before, you're going to need the object that has the data. But there's a catch. Now you need a device to get that data back. It's an extra dependency that we didn't have before. And it gets way worse for the more advanced technologies. To read information from a hard drive, you need that hard drive, plus a computer you can plug it into, plus software that knows how to access it. Our information is now part of an ecosystem. It needs something else in order to survive. What sort of implications does that have for us? Well, let's take a look at two similar pieces of information stored in two very different ways. We can start with the familiar. A book, classic. This one in particular is about 1,000 years old, and it's called the Doomsday Book. But don't let the name get you down. It's actually just a land survey, and it is of great historic importance. You see, in 1086, William the Conqueror executed a survey of a large part of Britain, most of England, part of Wales. One of the driving forces behind this was to do a survey to figure out what sort of taxes were liable. So it included a list of the livestock and land holdings that the various people had. It also had a list of the towns and countries that they came across as they went. It is the oldest public record in Britain, one of the oldest in all of Europe, and it is absolutely invaluable for historians trying to understand the time period. Maybe taxes are not the grandest motivation for something like this, but good things come from strange places. The Doomsday Book is an important part of European history. Fast forward to the mid-1980s. As the 900th anniversary of the book grew near, the BBC decided to commemorate it with a modern equivalent. They would survey the country again, collecting videos and maps and interviews as they went. All told, more than 1 million people participated in this project. Just imagine that, 1 million people. The scope of the effort is just breathtaking. Now, the project took all of this information and computerized it, building a high-tech microcomputer terminal in order to access it. This is a Doomsday Trumbull. It was state-of-the-art in 1986. It was built on top of a souped-up BBC Acorn Master microcomputer, and it used the unfathomable capacity of the Laserdisc for optical storage. It offered users a really early example of hypermedia. You could zip around a map of the country using a trackball and pull up photos and video clips. A high-tech project showcasing cutting-edge technology. What could possibly go wrong here? Well, let's reflect. By the time the 21st century had rolled around, the original book still looked the same. However, the Doomsday terminals sort of disappeared. You see, when the initial public publicity died down, they just sort of sat around until they broke. Replacement parts were hard to come by and expensive too. The computer they were based on, the BBC Acorn Master, was a proprietary 8-bit microcomputer that stopped being manufactured in 1993. Laserdiscs, the storage medium, never really caught on, and by the dawn of the 21st century, they were also no longer commercially available. And even during their heyday, they were extraordinarily expensive. The drive they used for these terminals cost about $15,000 if you adjust it to modern currency. The Doomsday Project was stored in an obsolete format for use with an obsolete computer. How could it be that a book written on sheepskin parchment would still be available to us more than 900 years later, when a state-of-the-art, multi-million-dollar project was in danger of vanishing 15 years later? What went wrong? There are a few points to consider. First of all, like all of our advanced data storage, the Doomsday Project lived in a complex ecosystem. And in this case, that system was not designed to last. The information was stored in a proprietary format, and it was accessible to, and here's the more important aspect, duplicatable by a very small number of people. It depended on proprietary, uncommon hardware that souped up Acorn computer and a Laserdisc player. There was no way for your average person to have their own Doomsday terminal, which meant that the project was destined to become less accessible as time went on, not more accessible. This is the exact opposite of the original book, which could leverage advances in the printing press technology that would let more copies flourish. And finally, the project was temporary. It wasn't designed to last. It made use of cutting-edge modern technology. They just wanted to build a compelling experience. When the project was over, there was no archivist to ensure that it would remain accessible. It wasn't even on anyone's agenda. That role just did not exist in 1986. There was no one to maintain the machines. There was no one to move it to PCs when those came around. There was no one to upload it to the web. It was forgotten. And this really gets to the heart of what we need for these systems, for our historical documents. How do we ensure that the information is still available by the time it has become historic? There are a few requirements. We need a robust ecosystem that doesn't rely on anything proprietary, rare, or expensive. We need information and the tools to access it to be widely available to as many people as possible. We need to make the information easy to share so there are as many copies as possible. And finally, we need to pay attention to it. We need to ensure that as time passes, it remains accessible. What is this system? Does it exist? Not quite. The web as it exists today has a lot of the characteristics we need. But without constant upkeep, information can still just vanish. Groups like the Internet Archive are trying to solve this, but it's an uphill battle. But even if it's not perfect today, though, it's probably destined to solve the problem. The web is the ultimate robust, ubiquitous system. It's accessible almost everywhere to almost everyone. And that brings me back to the Doomsday Project. In 2001, as the realization dawned that we were on the brink of losing something amazing, a project was started to revive it. It was largely the work of one man, Adrian Pierce. He painstakingly reverse engineered the project and presented a copy of his new version to to Britain's National Archives in 2003. His efforts were noble, but information of such historical importance should not be in the hands of dedicated individuals. And so we come back full circle to the BBC. Next month, the BBC is going to launch Doomsday Reloaded, a web-based version of this project. That means after 30 years, the information is finally going to be accessible to the people who made it in the first place. And a little piece of history will have been saved. Let's hope we've learned something.